The start will show the individual helper circuits. So this is just the counter. Basically, using some muxes to help with selecting what we want to write. So as you can see, if phase edge is high, we want to give this value. Well, when phase edge is high and QT sync is low, we want to count up. So I'll just pulse the clock. You see that's going in. When phase edge is low, and regardless of whatever we have, it's not going to do anything. And when reset is high, gives the origin value. And that's pretty much it for the counter. The register file is relatively simple. For writing, if it's at the state that it's supposed to write at, which is typically like state 3, state 5, state 7, state 9, and state 1, where reset just resets it to the origin. In this case, we take the origin to be 0 just because it simplified the circuit a bit, but it is possible to set it to another value. And also, there's reading enables. As you can see right here, this is for enabling word 0 to be read from here. And this is the word 1 enable, word 2 enable, and so on and so forth. So that's pretty much my register file. So this is my FSM for the robot arm final project. And currently it's at its 0 state. And when I do enable the ticks, nothing's really happening. And it's not going to change anything because there's no real input. The input's 0 and it stays at that state. So right here you see I have 2 clocks, and that's just for input purposes. So say the robot arm is moving up, and I later want to record that movement. So this simulates the robot arm moving up with the phase edge pulsing up. Oh, shoot. Oh. So this simulates the robot arm moving up with the phase edge pulsing with QT sync 0, and this counter just reading that input. And you can see where it says lost bits that this is in fact counting up. But that's not being written to any words yet because action button hasn't been pressed. And so let's try writing in a word. So right here you see it went to state 0, 0, 0, 1, 0, and then 0, 0, 0, 1, 1. And this is the writing state, and that's why these are all don't cares right now. So from the comparator right here. So right now it's writing the counter value to word 0. And let me just change the frequency so that gets to a word that we could actually read. So so that's a pretty decent value, and let's continue. So we got the word we want written, and so we go back to the 0 state. Oh, okay. So now we go back to the 0 state, and say we hit the action button again, and now it's checking. Saw that word 0 was not equal to the origin, which is 0, all bits at 0, and now it's writing to word 1. So let's speed this up so that it can have a value that we can actually see or write to the word 1. So we have a value written to word 1 that is different than a value, different than word 0. And now we go back to 0. And to write to word 2, we will hit the action button again. See, it skipped over word 1 and word 0 and is now writing to word 2. And yeah, let's do that. So word 2 is what it is and goes down to 0, and as you can see, it checks each word to see if it's equal to the origin, and now that it sees that word 3 is not equal to the origin, it writes to it, and we'll just speed this up. Okay. And this next state is an interesting one, because once I hit the action button again, it's going to go to state and compare the counter value with each word value, starting with word 3. And then it'll output directions and steps as to where the robot arm should go relative to that position. So when I hit it, the action button goes through each word, seeing that it's not equal to the origin. And now, see, this is at state 11, and it's saying to step down because the current counter value is greater than the word value. So we have to change Qt sync manually to make that happen. And once this counter value equals this word value, it will say, it will go to the next state, and that will check where the counter value with respect to word 2. Oh shoot. Okay. Did I just do this? Or... Okay, yes, sorry, I didn't catch that really quick, but it just went to the next state, 01101, and immediately went to 01110. And now that it sees that the counter value is greater than the word value, it will step. And I'll use a slower frequency this time, that it's a little easier to catch. So as you can see, once counter value equals word value, it goes to the next state, comparing word 1 and the counter value. And now that it sees that word, oh wait, it hasn't seen it yet. So let's change this back and enable it. Basically, saw that the counter value is greater than word 1, and it's telling us to step down. So once we get at a value equal to the word value, it will go to the next state, and then it'll compare the counter value and word 0. And it sees that the counter value is greater than word 0, so it tells us to step down with direction equal to 0. And we keep doing that until counter values for word value. And then we return to that same state, comparing the counter value and word 3. And this will loop, giving directions and steps according to different word values and different counter values.